Hello everybody. Now we will discuss about the inverse trigonometric function. So first of all we will try to understand the inverse of a function. Corresponding to every bijection function a to b. Bijection means the function should be 1 1 on 2. Then there is a function a to b. A means that is your domain and b is your range. So if you are taking the inverses there, we are going to interchange, means domain become a range and range become a domain is there. So to take the inverse of any of the function, then function should be 1 1 and on 2. There exists another function g b to a, means now your range become a domain and domain become a range, defined by gy is equal to x if and only if fx is equal to y. Means you can take the inverse of any one of the function if it is 1 1 and on 2 is there. Like for example, what you are taking, there is a function a to b, the element of a is 1 2 3, element of b is abc. There is a function a to b, so 1 2 a, 2 is associated with b, 3 base c. So this is your 1 1 on 2 is there. Now this is your domain of this one is 1 2 3 and range is this one. But if you are taking the inverse of this one, then another function we are taking here. So gy will be equal to x if and only if fx is equal to y. So this g is the function b to a is called of f a to b and is denoted by inverse. So this is the inverse of this function. See, here there is a function a to b. But if you will take the inverse, then f inverse will be b to a. So here is a is your domain and b is your range. But if you are taking the inverse of this one, then your range become a domain and domain become a range. So we can take the inverse of any one of the function if the function is 1 1 on 2. Have a look. Okay, now the very important point we are going to discuss about the inverse of the function. We know that trigonometric functions are not 1 1 and on 2. Trigonometric functions are not 1 1 and on 2. Even then, let sin x we are taking, then we are going to take the inverse of this one. That we want to understand. The trigonometric functions are not 1 1 and on 2 over their natural domain. In a particular domain, they are not 1 1 and on 2 and range, and hence their inverse do not exist. So inverses do not exist of any trigonometric functions. Even if the function is not 1 1 and on 2, then we are taking the sine inverse. So that we want to understand what exactly we are going to do here on. See, first of all we will try to understand this function is 1 1 and on 2 or not. See, if the y is equal to sine x you are taking, this is your function. If you are going to put the value of sine x is here, suppose you are going to put 0, because it may be minus infinity to plus infinity, any value you can put there only. So if you are going to put the sine 0, that is 0. If you are going to put sine pi is also equal to 0. Sine 2 pi is also equal to 0. It means for the value which you are going to put here only, these are your domain. These are, you can see the domain. If in case if we talk about the relation, then these are your range. So for 0, your range is 0. For the pi is also 0. For 2 pi is also 0. So this function, I mean this y is equal to sine x, is not a 1 1 function, because to become a 1 1 and on 2, it should be a 1 1 and on 2 if you want to take the inverse of any trigonometric function. It means y is equal to sine x. The function which you are taking here is not 1 1 on 2. Then how can you take the inverse of this one? So that is also we will discuss. Have a look now. Okay, so we got it here only, then y equal to sin x. This is not a 1 1 is there only, because for the various value we are getting the same value is there only. To become a 1 1, one element means एक image होना चाहिए, that is already we discussed is there only. Now this is the concept is here. It means this function which you are taking here only, you cannot take the inverse of this one. So what we will do, if we restrict their domain and range, if we restrict, see, from here, this minus pi by 2 from here to here, if you are going to restrict, यहाँ से यहाँ तक, here, minus pi by 2 to this plus pi by 2, if you are taking this portion is there, this one, and you are going to put the value from this minus pi by 2 plus pi by 2, you will get the various values is here. You will get the different values, you can say, from here to here. So if we restrict their domains and the range, then their inverse will exist. Means minus pi by 2 to plus pi by 2. If you are going to put, you will get the different values is there. Means unique, you can say that you will get the unique values you will get. If you are going to put, suppose मैंने A रखा, then you will get 1. If I am putting the B, then you will get the 2. It cannot be, then for A is coming 1, then B is also coming 1 is there only. So if we restrict their domain and range, then we can take the inverse of that function in this one only. So here is, keep in mind, the trigonometric functions are not 1 1 and 1 2. So we cannot take the inverse of their functions. If you want to take, you are bound to restrict their domain and range only, then you can take the inverses there. So this is the graph for y equal to sin x, and if we draw the graph for inverse for the y equal to sin inverse x, what will be your graph is there? Y equal to sin inverse x. See, in y equal to sin x, on x-axis we are taking, this is pi by 2, pi 3 pi by 2, on y-axis there. But if you will take this one only, so the value which are on the x-axis will come on the y-axis, and value on y-axis will come on x-axis there. So what will, because you are taking the inverse from minus pi by 2 plus pi by 2 is there only. So look at here now. So this is your x or x dash. Here you can take the minus 1 plus 1. Here is the pi by 2 minus pi by 2. So your graph here means your point will be here. Here is minus, so you will be, here is there only. So your graph will be like this one. This is your y is equal to sin inverse in this interval minus pi by 2. Here is minus pi by 2 to plus pi by 2. So the value, this is, you are taking the inverse. So we can take the inverse of this trigonometric function, that is sin x, in this portion from minus pi by 2 pi by plus pi by 2, where you will get the unique value for every value of minus pi by 2 pi by 2. We are going to put it in this function is there. So you will get the graph for the y equal to sin inverse is this one. So have a look. Okay, now this is the table is there. This is the very important to understand this one for this entire chapter. Function and domain and range. Then question is that how can we remember this table? So look at here now. These sin inverse, cos inverse x, tangent, cosec, secant, this one, sec and cosec, these six have a group. They are actually in group is there. See, sine, this sine and tan and this cosec. Sine, tan and cosec, they are in one group. And cos inverse, cot inverse and this sec inverse x, they are in one group is there only. See, how can you understand this one, or how can you remember this one is there? See, this is the quadrant you can take. This is the first quadrant, second, third, and this is fourth. So if we take here is, this is minus pi by 2 to plus pi by 2 you are taking. Here you can take 0 to pi. 0 to pi you are taking. The important point is there, nothing is in the third quadrant. So forget this one. Nothing is in this third quadrant. No inverse function will be in this third quadrant is there. So from this table we will try to understand. See, now this sine and tan and cosec, they are in one group. Always they are one group. This is the way to remember this table is there. See now how sine inverse x, if we talk about the ranges minus pi by 2 plus pi by 2, means these are from here to here. They are in this one, means sine inverse x, tan inverse x and cosec inverse x. Look at here now. This is minus pi by 2 to plus pi by 2, that is closed interval. We will try to understand this closed and open. Don't worry. Tan inverse x is in open interval, just see minus pi by 2 to plus pi by 2. And in cosec is also, see here only, minus pi by 2 to plus pi by 2, but theta is not equal to 0. See. So these three are in same group. You can now see sine inverse x minus pi by 2 plus pi by 2 is defined. So your range, this is, and domain is the minus 1 to plus 1 is there only. But if we talk about this tan inverse x, tan inverse, here we are going to write the open interval, means these are not included. It means, see, if we talk about this tan inverse, tan x you will write sin x over, we can write the, like cos x is there. So if you are going to put the value of cos x is here, just you are going to put the pi by 2 plus pi by 2 or the minus cos pi by 2 you are going to put cos pi by 2, that is 90. So this is not defined. So this is not defined. So tan is not defined on this interval, minus pi by 2, this one. So this pi by 2 and this one is, we are supposed to keep in open. This one. So theta is greater than equal to minus pi by 2 but less than equal to plus pi by 2 is there only. If we talk about here is there cosec inverse, cosec is there. If we talk about the cosec, if you want to write cosec x, that is equal to 1 over sin x. So if you are going to put x is 0 here, so at 0 this is not defined. So your theta cannot be equal to 0. So it will be minus pi by 2 to plus pi by 2 is there, but 0 is not there. So you can write down in this way or you can write down in this way. This is also one of the ways there. Minus pi by 2 plus pi by 2 minus 0. So these three are in the same group. These three always are there in the same group. And other this cosec inverse, cot and sec inverse, they are in one group is there. These three are in one group, and these three that you can see, this cos inverse, cot and sec inverse, they are in the another group. That is also we will discuss. So have a look. Yes. Now talk about this one only. So cos inverse x 0 to pi in closed interval. So these three are in one group, means cos inverse x, tan inverse x, sorry, not tan, this is cot inverse x and sec inverse x. These three are in one group is here. See, cosec in 0 to pi in closed interval, that is defined. Cos x is defined in 0 to pi is there. But this cot x is not defined on 0 in this one, because cot x you are taking, that is cos x over, you will take the sin x. So sin 0 you are going to put, sin 0 is 0 and cos 0 is 1. So 1 over 0, it is not defined. It's not defined. So that's why they are in open interval is there. Similarly, sec inverse. Sec inverse is 0 to pi, but it is not defined on pi by 2. Not defined on pi by 2. Here is there. This is not defined as sec. Sec you will take, then sec x you will write 1 over cos x. So if you are going to put pi by 2, that is 0, so that is not defined. So you can say this one, you can write down this one is, if you want to write this one is there, 0 to pi minus pi by 2. This is there. So these are the range, and these range is also, you can say, the principal branch is there, principal value branch is also, you can say. So this is the very important to remember. This one is there. Always keep in mind sine, tan and cosec, they are in one group. They behave like approximate. And cos inverse x, tan, cot inverse and sec, they are in one group. Their groupism is there. Among these 3 6, there is a group. So this sine inverse x and tan inverse and cosec inverse behaves like approximate, and similarly this one. Always you will see these 3 are in one group and these 3 are in one group. Now we will discuss, then you can understand what is the exact meaning or what exactly we want to discuss. So have a look. Okay. One more point I would like to discuss here only, so you can understand meaning of symbol sine inverse x. Because sometimes what the children are going to do, they are going to write sine inverse x is equal to 1 over sine x. But this is not equal to this one. Remember, if we think about the graph is there, no doubt is there. The graph for the sine x is this one. Mean this is your x-axis and this is your y-axis. But if we draw the graph for this sine inverse x, then your graph is coming like this is there only. This is your x-axis and this is your y-axis there only. But here exactly what we want to say, another way of the writing this one, suppose sine theta is equal to x is there, so you can write down theta is equal to sine inverse x. Theta is equal to sine inverse x. Okay? Sine theta is equal to x, that can be written as theta is equal to sine inverse x. But this sine theta is lies between -1 to +1 is there. When the axis lies between this one is there, this x, theta is here only. So the important point which we want to discuss, sine inverse x defined as a rational relation and not a function. Sine inverse we are going to define, sine inverse x we are going to define as a relation is there only. See, this is already we discussed is there here, because until if it is not a 1 1 and on 2, you cannot take the inverse of the function. So it's not a function, because for a given value of x, sine inverse x has infinitely many values. Here you are going to draw the graph of this one, many values are coming for the same value. For 0, then pi by 2, then pi, likewise you are getting is there only. See, one important point is there, this is the example we are taking. With the help of this example, we will try to understand why, when this function is going to become when this sine inverse x is going to become a function is there. So sine inverse 1 by 2 you are taking is equal to theta. So it means you can say sine theta is equal to 1 by 2. And value of the 1 by 2 in sine is pi by 6, sine 30. So this is already you read in the 11th standard. Then sine theta is equal to alpha is there if, then theta is equal to n pi plus minus 1 raised to power n into alpha. This is the, already you know this one. So sine theta is equal to sine pi by 6. So here we will apply this one. So theta is equal to what? N pi plus minus 1 raised to power n into pi by 6. Now n is 0, plus 1 or minus 1, plus 2 or minus 2, plus 3 and minus 3 is there. So if you are going to put the value of is here is, in place of this n, you are going to put it 0 is here. N is going to put 0, you are going to put it, you will get the pi by 6. You are going to put 1 is here. So this is 1 into pi minus 1 raised to power 1. So minus 1 is there. So pi minus pi by 6, you will get 5 by 6. Then minus 1 you are going to put. So you will get this is. Likewise the other values you will get. So infinite values you are getting as you are going to put this one. So that's why I have written, so you can understand. So the important is here, hence this sine inverse 1 by 2 will have infinite many values. Infinite many values, this one is there. But if we restrict this is the most important point, that is already we discussed in the beginning. The values of sine inverse x to any of the interval, like minus pi by 2 to plus pi by 2, you will get the interval is there, minus plus pi by 2 to 3 pi by 2, or minus 3 pi by 2 to minus pi by 2. Then corresponding to each x will get only one value of sine inverse x. In this interval, if you are going to restrict this one in a particular, that is already we discussed, here is, we are going to restrict this one only. We are going to take the inverse in this interval, means minus pi by 2 to here. This is the minus 1, that is you are getting, this is your minus pi by 2 and this is your plus pi by 2. So here to here we were taking the inverse of the sine is there. So one value of sine inverse x, then sine inverse x will become a function. This is the symbol of sine inverse x is there. So have a look.